All right, this video is to demonstrate how we will use algebra to solve problems involving the center of triangles, and measurements are given in algebraic expressions. So in these, we're going to find the value of x and then the indicated measurement. In number one, we're told that D is the incenter of triangle ABC. And so the result of that is if D is the incenter, then we know it was formed by all the angle bisectors of at the vertices. So for instance, I know that this angle here is congruent to this one. I know up here at vertex B, that angle will be congruent to that one. And then lastly at vertex C, I know that this angle will be congruent to this one. All right, let's read a little bit further. If the measure of angle ADB, so ABD, if the measure of angle ABD is 4x plus 6, so we're talking this angle right in here. This is 4x plus 6. And the measure of angle CBD is 5x. So this one right here is 5x. Find the value of x and the measure of angle ABD. So we're going to find the value of x, and then we're going to find the actual measure of that angle right there that we were given 4x plus 6 for. So since we know that the angles at each vertex are congruent, the two angles, because D is the incenter and it's formed by angle bisectors, then we can take those two measurements, 4x plus 6, and we can set them equal to one another, is equal to 5x. Then to solve, I would start by subtracting 4x from both sides. On the left, those will cancel out, leaving us with only 6 on the left, and on the right, we'll have x. So that's the first step. We found the value of x. X is equal to 6. The next step, they want us to find the value of angle, or the measure of angle ABD, which is the one we were told had a measure of 4x plus 6. So what we're going to do now is we're just going to substitute in. So we're told that the measure of angle ABD is equal to 4x plus 6, but since I know that x, based on our previous work, is equal to 6, I'm going to substitute in. So 4 times 6 is 24, plus another 6 gives us that the measure of angle ABD is 30 degrees. So again, if for some reason you know that the angles given, or if you have side lengths given that you know are congruent, set the measurements equal to one another, solve for x, and then use x to substitute into what they ask you to find. All right, let's look at another example. I is the centroid of triangle QRS. All right. Well, we know with the centroid, our big property here is that these lines that form our point of concurrency have a ratio of 2/3 to 1/3. Or I could also say that, for instance, QI is twice the length of IZ. All right. So if RI is -6 plus 2x, so we're coming in, we're going to say RI is -6. So right here, -6 plus 2x. And IY is 2x minus 7. There we go. So IY is 2x minus 7. We need to find the length, or sorry, find the value of x and then the length of RY. So as I was saying, because I is the centroid, we know that any of these line segments, the medians, if you will, that form our point of concurrency, the top half or the longer piece is twice the length of the shorter piece. Or you can think of it as it's 2/3 of the overall thing and 1/3 of the overall median. I called it a thing, it's a median. So what I'm going to do here is, since I know that Ri has to be twice the length of Iy, I will take my expression for Ri rather, and I know that it has to be twice the length of Iy. So if I took Iy and repeated it and put it at the end of itself, then that would be the same length as Ri. So now we're going to substitute in our algebraic values. So we're going to put in -6 plus 2x for Ri. On the right-hand side, I have to go ahead and put in a 2, and then I'm going to put in my algebraic expression for Iy, and that is 2x minus 7. And now we're going to solve for x. So first things first, I'm going to leave the left-hand side alone, because what I want to do first is this distributive property over here. So I'm going to take this 2 and I'm going to distribute it to the 2x and to the minus 7. So that's going to give us 4x minus 14. What I'm going to do next is I'm going to, let's see, I want to collect my x's on one side. Let's subtract 2x from both sides. On the right-hand side, those are just going to cancel out. I'm sorry, on the left-hand side, rather. And that's going to leave us with -6 on the left. And let's see, 4x minus 2x will leave us with 2x plus 4. I'm sorry, I don't know where I got plus 4 from. Should be minus 14. Minus 14. And then my next step for solving, let's see, I would go ahead and add 14 to both sides. Add 14 to both sides. On the right, those are going to cancel out. On the left, let's see, -6 plus 14 is going to give us a positive 8. So 2x is equal to 8. So then finally, to finish solving, let's see, I could divide both sides by 2. The 2's would simplify to 1, so I have 1x there. And 8 divided by 2, this is going to leave us with x is equal to 4. So that's half the problem. We found the value of x. And that's what it asked us to do first, find the value of x. Now it wants us to find the length of Ry. So it wants this whole thing, all right? It wants the whole thing. So there's a couple of ways we could do this. I think maybe the easiest way is just to take those two algebraic expressions, add them together, and substitute in the value of 4 for x. And so that's what I'm going to start off by doing. Now, there are other ways to do it. You could use the fact that this is 2/3 of the whole. That's 1/3 of the whole. You could multiply the length of Iy by 3 and then substitute for x. There, like I said, there's a bunch of ways to do it. Again, I think the most straightforward way is just to add those two segments together. Whoops, and I want to substitute in my value of 4 for x. Now that we know what x needs to be. X needs to be 4. So that's going to be my length of Ri. Then I'll say plus 2 times 4 in place of x minus 7. And now I'm just going to simplify. So I have 2 times 4s. So that's going to give us -6 plus 8 plus 8 minus 7. -6 plus 8 will give us 2. And 8 minus 7 will give us 1. And so it looks like the length of RY in total is 3. Right? RY is 3. And that concludes this video. Now, we did not show an example of the circumcenter, but just remember, circumcenter is formed by perpendicular bisectors. So that opposite side from a vertex, the two pieces that the side is divided into would be congruent. All right, until next time, happy math.